Alright, today we're going to look at the second part of 4.6. It was extended for a couple of reasons. First, there was a lot of new material in the lesson from before, and I didn't want to give you too much at once. Also, it helps to have slight experience with some things before seeing it. For example, in terms of whether something is a function or not, it's at least good to know a little bit about what's going on with it. Talking about a mapping, one thing you're going to see in today's homework is a mapping, or just a general idea. But a mapping is a visual representation of a relation. So if you just copy this example real quick, what you do for a mapping is you put your domain or your input values in first, and again, just like you normally would. So the way we did domain yesterday, we put the smallest number to largest. So -3 is in this list, 1, 2, or 2, 1, so we don't repeat it, and there's a 5. Then you put right next to it your range values, which would be your out values, and my range values are -1, looks like 4, 6, and 9. And so again, this is my domain values. That's why I said the experience helps. So we did our domain here, -3, 1, 2, and 5. Our range values -1, 4, 6, and 9. And all you do in a mapping is you draw arrows from your input value, which is your domain, to your output. So 1 goes to 6. So what you do is you simply draw an arrow from 1 to 6. 5 goes to 4. So we simply draw an arrow from 5 to 4. -3 goes to 6. So we draw an arrow from -3 to 6. 1 goes to 9, so we draw another arrow from 1 going to 9, and -2 leads to -1, and that is your mapping. Alright. What we discussed yesterday is that a function is a relation where each input only has one output, and that means we should know exactly where our output is going. So looking at the previous map here, if I want to know where -3 is going, I know it's going to -6. If I want to know where 2 is going, I know it's going to -1. I know 5 is going to 4. The problem is that 1 is going to either 6 or 9, and because that one value is confusing, it means it's not a function. Again, because this number here leads to two different values, this is not a function. You might want to write that there, and that's because of the number 1. Again, the number 1 is confusing because it leads to two different spots, and that way you understand what it means whenever they ask, is it a function in terms of numbers? You know to look at it and say, you know what, I know where 3 is going, I know where 2 is going, I know where 5 is going, but once I don't know where 1 is going, there's going to be a problem. I want you to imagine a calculator where when you type in 2 plus 2, sometimes you get 4, sometimes you get 5, sometimes you get 3. That's not a good calculator. That's not a good machine. And a function is a machine. And so what you want to know is whenever I put this number in, I want to know exactly what's going to come out of it. Alright? So look at a second example here that you should copy also. Again, my n values are -2, 5, 6, and 8. My out values are 3. That's it. And so we know that 8 goes to 3, we know that 5 goes to 3, we know that -2 goes to 3, and we know that 6 goes to 3. Even though everything is going to the same location, I know where it's going to end up. I know that -2, when I put in a -2, I know 3 is going to come out. I know when I put in a 5, 3 is going to come out. I know when I put in a 6, 3 is going to come out. I know when I put in an 8, 3 is going to come out. None of those are confusing. I know exactly what's going to come out with my input value, and so that means yes, it is a function. And again, that's because I know exactly what's going to come out. So you might be thinking, well, but everything goes to 3, but watch this. What comes out whenever I type in 2 plus 2? 4. What comes in whenever I type 2 times 2? 4. What about when I do 1 plus 3? 4. What about 5 minus 1? 4. It's okay for it to have the same output. You just want to make sure that whatever I type in 2 plus 2, that I get the same answer every time. That is a good machine. And so as long as you know exactly where your input is going, that makes it a function. At least that's your general idea of what a function is. So again, the second type, the second topic of the notes discusses two topics talking about reasonable domain and reasonable range. The essential question there is kind of about this here: what is meant by reasonable domain and range? And a reasonable domain and reasonable range represents realistic values. Again, it's just things that are realistic that can be used for a function. Keep in mind, we made tables for word problems, and it was a previous lesson somewhere where we were selling something or talking about profit. It says something like a profit earned from selling fruit in a stand can be modeled by the function p of x, which would be profit of x equals 13x minus 10. So this represents how much money we make from selling fruit. Assuming that x probably represents the number of pieces of fruit sold, we could think about the fact that, or what I said back then, was that it does not make sense to sell -5 pieces. So x should not equal -5. X should not also equal -4, anything negative at all. It should not be that I could sell -100, -200, -1, -2 pieces of fruit. And so that means that those numbers don't make sense. Those are not reasonable numbers for my domain. Again, that's what I'm putting into the function. So this is my domain value here. Again, that does not make sense, so therefore that's not what I'm going to do. Alright? So 0 is a reasonable low value because 0 should be a number that I could start with. The starting number of this problem here should be 0 because the lowest number of pieces of fruit I could sell would be 0. But does it make sense that I would sell 1 million pieces of fruit at my stand for that day as a high value? I mean, it could be, but it's going to be very rare, and that's not probably the most reasonable thing. Now, you could sell 1 million things, but if you're talking about a problem where you're just selling fruit at a stand for a day or for whatever time, like, it just depends on what time we're talking about. That reasonable number, that reasonable high number also has to be considered. And so I won't say that 1 million is not reasonable, but we don't really know the whole story. But what I'm saying is that when we're talking reasonable domain and range, we need to make sure we read the problem and try to tell the person or tell the problem what the range of values of input values and output values are. A reasonable domain is a set of values that can be expected in a situation. A reasonable range is a set of results that can be expected using the domain values. So again, the reasonable domain is a set of values. That means the numbers we can put into it. Because remember, domain is your input. You might want to put that for your problem there. Again, domain is what you're putting into the function. And a reasonable range is a set of results. That means those are the numbers that are coming out. That means when I plug in my x, what numbers are going to come out? When I plug in all these x values from 0 to 1 million, what are my numbers that are going to come out of that problem? Again, that is your reasonable range. You have to know the reasonable domain before you can calculate the reasonable range, because the reasonable range is what comes out from putting in your domain numbers. Alright? So as we close this out, excuse me, problem's going to look something like this. You're selling candidates. I don't know what a candidate is, but I needed a word problem. But you're selling candidates at a park. You'll earn 67 cents on each candidate sold. You have ordered enough supplies for 250 candidates. The function P of C equals 0.67. C represents the profit P. So again, we know this represents profit. You earn for each candidate, so we know that represents the number of candy sold. Find a reasonable domain and range for the function. So here's what we've got to do. Your domain, your reasonable domain. Again, you're talking about this value here because that's what I need to put in. So C represents the candy. Is it possible to sell negative pieces of candy? No. So that means that I got to find my lowest amount of candy I could sell. And in my opinion, the lowest number of candidates I could sell at a park is 0. Because maybe nobody likes them, maybe they're just terribly packaged, who knows, but 0 is going to be my lowest point. And so 0 is less than or equal to, and this is kind of like what you did in chapter 3, 0 is less than or equal to your number of candidates, which is C. So this means that C is going to be 0 and higher, but of course there's a high number too, and so we need a high number also. Remember this, again, this was your compound inequalities. And if you read, it says we have ordered enough supplies for 250 candidates. So if we order enough supplies for 250, I don't think we can sell 251, 252 because we only have that many supplies. And so the number of candidates I can sell is anywhere from 0 to 250 because that's all that I ordered. I didn't order enough for 500, 600, 700. I ordered enough for that much. So again, the number of the reasonable domain for this problem is anywhere from 0 to 250, because those are the only numbers I can sell. I can't sell negatives. I can't sell more than 250 because that's all I have. So what I do now that I've found my reasonable domain, is I take those numbers and I plug them in to see my reasonable range. So I take 0 and I plug it in for C. So 0, again, this is my input value. If I put 0.67 times 0, of course the answer is 0. So 0 is less than, my function itself is P of C, so that's what goes here. And now we need our high number, and the way we find our high number is by plugging in the high number of C. So if we were to sell all of our candidates, how much money would we make? So we would put 0.67 times 250 to get the answer of 167.5. And so this means that the number of candidates I can actually sell is anywhere between 0 and 250. That's reasonable. And the amount of money I can make is between 0 and $167, or $167.5. So again, the key idea here is make sure you understand you can't sell more than, or you can't sell fewer than 0. So 0 is your starting point. Also make sure you use less than or equal to, because both of these bounds are included. So you can't sell any less than 0. You can't sell any more than 250 because that's all the information I bought, all the supplies I bought. And in terms of my range, it's that 0 candidates leads to $0 and 250 leads to 167.5 bucks. Just don't forget that you have to put that function part there as it is on the computer, otherwise it's going to mark you wrong. All right. Final thought is study, study, study. Please, it is less important that you finish the homework than it is that you recall the necessary strategy for each type of homework problem you're going to see. So please make sure you glance through your Math Excel homework whenever you're finished or whenever you're caught up, and make sure that you immediately can look at a problem and say, this is a problem where I do this, or this is a problem where I do that. Because if not, you need to spend more time with it so you don't fall short on any of your assessments. You have one tomorrow, so make sure that you're ready for that. Again, any question we have seen, that means even questions from last week are legitimate questions for this quiz tomorrow. So make sure that you are keeping up with all that stuff. And again, this advice holds for any math classes you take. So if you want to start learning to prepare for your math classes in general, this is what you do. You do your work. You kind of go back. You look over each question and say, I remember doing that. I remember doing that. So if you remember doing it, that's fine. Just don't lie to yourself. But if you look at one and say, I don't remember how to do this, that is where you want to get your paper out, work that problem out one more time, and make sure that you remember how to do it. Even if it's just working the same problem, knowing the answer, as long as you take your brain back through that, you're trying to solidify your memory of that problem. So outside of that, your homework is waiting. So let's go ahead and get started. Good luck.